We have a really great website where we put all of these webinars. I believe we're on the 62nd webinar that we'll be uploading to the page here. You can always find it there, and you can also always register for our upcoming events like this from our website. So if you know Buckley at all, you should recognize a lot of the logos here. A lot of people recognize us as the price and GreenHeck rep. We have a really great, diverse, and complementary product line. We have air distribution products, mechanical products, control products, and there might be a new one here that you recognize, and that's Fujitsu. We want to not only be known as a price and GreenHeck rep, but also the Fujitsu rep. We are really excited for that relationship, and I'll talk a little bit about that here in a bit. But first, we're going to talk about some energy code updates, the passive house design implications, some compartmentalized ERVs for passive house, and some passive house certified DOAS units that we have that we're excited about. And then, of course, the Fujitsu heat pumps and VRF systems, and then some Buckley condenser supports, stands, and pipe portals to go along with those. And then we'll talk about fire-rated air distribution details and some of the updates that we've applied to those. And finally, we'll talk about jet fans, garage jet fans, and some laundry exhaust systems that tend to be found on a lot of multifamily design applications. So starting off with the energy codes. This is something that you'd find on the government website. You'll notice here, if you're familiar with this stuff at all, that Massachusetts is finally dark green. Actually, last year, they were the light green. They were actually 2018 IECC was the base code. But when you think about Massachusetts specifically, you really don't think about base code in general. We'll talk about that more in a second. But in base code, IECC 2021 with mass amendments is the base code. That's 780 CMR 10th edition. And more recently, the residential and commercial are dictated by Chapter 11R and Chapter 13. But most importantly, in this market, we're dictated typically by stretch code, which is ICC 2021 with mass amendments and stretch code amendments. So that takes from 225 CMR Chapter 22 and Chapter 23. And then as soon as you start needing specialized energy code, you still have to start referencing the appendices RC and CC. So this is what the map looks like. At least this is what it looked like as of a couple weeks ago when I made this presentation. If I were to sum up the compliance pathways for Group R buildings for every code section, you basically end up with 3 sections, like I said: base code, stretch code, and specialized code. And within base code, you have 4 compliance pathways. It's a typical ASHRAE 90.1 energy model, a HERS 52 rating. Then you can also use stretch code or specialized code, which we'll get to in a second. Now, in these regions, base code, for the most part, is really only found in 50 towns, 50 municipalities. And it would actually use ChatGPT to kind of come up with the population percentage for each of these. Base code per population actually only represents 9% of the population. So there's a 91% chance that your Group R building will have to fall within stretch code or specialized code. And on top of that, if you're developing a Group R building, there's a good chance that people aren't going to be needing them in the base code regions because they're in less population dense areas. And if they are in the population dense areas just north of the city there, if you're looking at this region right here, those people, I mean, if you're developing a base code building, there's a chance that they might be concerned that there's going to be, a movement to stretch code. So the point is, a lot of these buildings that we're talking about are all stretch code or specialized code. Within the stretch code compliance region, you could do HERS 42 or 45. However, it's worth noting that a lot of the energy efficiencies that you need for HERS 42 or 45 actually would be you're doing most of what you need to get passive house rating anyways, just without the stringent leakage test. Now, something worth noting is that the HERS rater would need to get paid, and you also need to pass a blower door test. It's not as strict as PHIUS, but the HERS rating actually only also applies to the apartments. So the shared areas or the amenity areas would still need to be separately permitted. Now, when you talk about passive house, sure, you do have that strict leakage test that we'll talk about in a second, but the incentives are much higher for Passive House. In fact, the incentives from Mass Saves pays $3,750 per unit. There's no incentive limit. There's no time limit on that incentive. And the incentives typically will cover all of your soft cost and even some hard costs too. So that means it'll cover your PHIUS fees, your verifier fee, your energy model fee with your certified passive house consultant. And then you actually have money left over after that to pay for your other costs, like actual construction costs too. So all that said, it's basically reasonable to assume that of the 91% population, all of those group R buildings are going to go passive house. All right, let me see if there's any questions. Okay, we got a good morning. That's good. Thank you. All right, so please send any questions in. I love the feedback if I can get it. We're gonna keep going. So what is passive house? Passive house is a compliance pathway, like I said, where you're basically your building should be pre-certified as meeting the prescriptive checklist of PHIUS Core or PHIUS Zero. So in order to do that, you got to work with a certified passive house consultant or a CPHC, like I just mentioned, that will coordinate a WFI model, which is your energy model, with PHIUS. Within that model, there are some absolutes, and one of those is that your ERV performance will absolutely require a minimum of 75% sensible recovery efficiency, or SRE. Now, that said, that's kind of like the bottom barrel. You need to typically you'll end up with about an 80% SRE requirement from the ERV. So envelope leakage test is also a big thing. And we'll talk about that in a second, but EC motors are going to be required. And then there's also some design implications. One of the big design implications that I've seen across the board is the typical apartment HVAC design has kind of changed. PHIUS likes to, so typically in the past, your ERV has always historically fed the return of an in-unit air handling unit. So that means that the systems are combined. You have one ducted supply and one return, and it kind of, you up your ERV efficiency with the efficiency of the unit. However, passive house doesn't really like that. They actually want to see your duct systems completely separated. The ERV has to supply directly to the space because they want to be able to measure that. Now, I know that some people kind of, I guess the point is, one of my engineers has had a conversation with them directly, and this is kind of a hard rule that has come out of that. So an ERV, by the way, can be in unit or fed by a central system. Now, I've talked to plenty of engineers about this, and just about across the board, they've all said the same thing. It really just depends on the project. There's benefits to both. One of the big benefits to having an ERV inside the unit is that the owner can bill the tenant individually for the electric used by that ERV. However, one of the downsides about that is that now you have more penetrations in the outside of the building, and you have to pass that leakage test at the end, which is very strict, more strict than the HERS rating. So it could be beneficial to have a central unit like a DOAS unit, but then you have to worry about some of the riser implications like fire barriers, smoke dampers, etc. So I hope there's I'm looking at the questions right now. All right. Yeah, I mean, just so everybody knows, I am going to be talking about other states too, to an extent, but I'm really kind of chopping off the main thing here, which is our Massachusetts passive house requirements. We'll get to some other equipment that we'll be able to use for other states in a second. Okay, keep going. So what do we recommend for this? Well, there's one that really stands above the rest for out of our units when we talk about in-unit ERVs, and that one would be the GreenHex Sync 180. It has a really great enthalpy, which we'll talk about in a second, of 2.3 CFM per watts. It's got a really high airflow range of up to 200 CFM. It exceeds code by getting your 84% SRE, and it even has it even passes the very low temperature test of -13 degrees. It has a built-in piezo ring, which will help you automatically balance them in the field. Has really simple controls. It has other some other nice functionality like a FID, which you don't really need in our state yet. It is required by California by Title 24, which is a fault indicator display. But for now, just know that we can do it. It also offers a mirrored configuration if you need it, and that unit has a pretty small footprint of 22 inches wide by 26 inches long by 10 inches deep. So it'll fit in most applications, especially where you have a 24-inch on center joist. One sec. Okay, so I had a comment that air balancing a centralized ERV is a nightmare. Well, we have a solution for that, just so you know. We'll get to it in a second. So moving on, this GreenHex Sync 180, like I said, it's got an 84% SRE at 32 degrees. It's really good for passive house apartment designs. This will shine brightly to the CPHC or the PHIUS certifier. This is something definitely worth designing around. But if you do, it's worth noting that you really should specify the efficacy on that drawing. The reason being is that this has a pretty high efficacy of 2.3 CFM per watt. When you do carry that in your woofy model, it's important to know that your watts are counted, right, as you develop that woofy model. And if you get a substitution from a contractor that might not meet that efficacy, it's important to know that woofy model might not necessarily work with a substitution, and it's important to carry it all the way through. So this is a great unit. It's really great for bigger apartments because it has a pretty high airflow. You actually have a high airflow of 176 CFM at 0.4 inches static pressure, 125 CFM at 1 inch, which is usually plenty. And then down here, right here, I have highlighted an HVI data point. Now, this is going to get a little tricky, so please give me any feedback if you don't necessarily get what I'm getting at. But when you work with these CPHCs or the PHIUS people, if you're CPHC yourself, maybe you understand this. They always like to reference these HVI data points, but they're constrained to the actual design conditions and airflows that they provide. So it's important to know that we can, at Buckley, give you the airflow performance with a pretty good guess of what that actual SRE is for any airflow or design condition, using what we have a calculated D rate. So this is basically our best guess. It's like an engineered approach at giving a CPHC real data. We use the HVI design conditions right here on the right, which is 32 degrees, 32 degrees, in the winter with its corresponding wet bulb temperature right there. And we developed using the core simulation data what the dry bulb and wet bulb temperatures are from the core simulation data for each airflow. Now, using the highlighted actual SRE, that highlighted number right there is an HVI data point. So at 64 CFM, at 32 degrees outside, with those HVI data points design conditions specifically, we were able to determine what the core simulation data is. I was able to calculate the SRE at that 64 CFM, and then I was able to get what the D rate is for basically the other losses in the unit, which includes like temp rise from the fans, filter, the static pressure from the filter, etc. So I was able to determine, here's the actual SRE for the other airflows, and we can also determine that using that D rate, your maximum airflow with this unit and still achieving a quote unquote 75% actual SRE is about 135.6 CFM. So I just got a question. Are there plans to make HVI certification equal to PHI certification? That's a great question. I don't know. That would probably, to be honest, be more of a conversation for PHIUS themselves. I know they work very closely with HVI because this is real data. So I don't know. It's a good question. I don't know the answer though. Sorry. Now, here's an example schedule. This is something that I developed for one of my clients. I guess the highlight here is that we can provide the actual data for the actual the unit using core simulation data, but then we can also provide the HVI data. And what I just showed you is the calculated SRE. Now notice too that I did specify the efficacy because again, that's important when you're considering substitutions to your WFI model. You don't want to end up with a substitution of an ERV that won't be compliant with your WFI model because then you won't get the PHIUS certification at the end. All right, here's another one. This is another great option from American Aldiz. So it's called the SystemAir Elite. It's the EK 150 TFX. So it has a pretty cool little feature here with swiveling ports, so you can actually get a top, oblique, or side duct connections. It's very high, highly configurable for most apartment sizes. Kind of unique dimensions. I will say it's a bit taller than most, but if you can find the right spot for this, it would definitely be a great option. You have high sensible recovery efficiency of 83% at 32 degrees, and that's at 66 CFM. And you can even get, it's funny because right now you couldn't really extrapolate that out, but we do have the core simulation data to once again kind of help you develop a schedule outside of that. Also has very good airflow, so 155 CFM at 0.4 inches static pressure and 117 CFM at 1 inch, and again, good efficacy of 2.2 CFM per watt. So far, I've shown you a couple options. This one is cost competitive. The next one is very cost competitive. This is a reverse-o-matic RERV D100 ECM. Now, this is without a doubt our most cost competitive high efficiency model that would be compatible with a passive house WFI model during design. And I say during design because I'd really want you to consider this on the front end because of its efficacy. You'll notice there that it's got a 1.8 CFM per watt. The airflow is a little bit lower at 133 CFM at 0.4 inches static pressure and 87 CFM at 1 inch. So it would be good for like a 1 or 2 bedroom unit, whereas the previous examples would have been really good for like even a 3 bedroom unit. So it's worth noting too that you could do kind of a hybrid schedule for your design where you could use both and make it really cost competitive. That way you for sure would see these in the submittal phase. So this is a very high efficacy. And down below, I actually highlighted the HVI data where there's actually 3 design points at 70 CFM, 81 CFM, and 95 CFM where it only decreases by 1% SRE per data point. So, pretty good SRE for the number of, for the airflow that you get here. Definitely worth designing around from the front end and could be a good substitution as long as the efficacy works. So kind of branching out of the passive house design criteria right now, this wouldn't necessarily, technically it would work because you're at 76% SRE at 81 CFM, but usually the CPHC likes to see a little bit more SRE than that. But it really would work very well for other, for either mass base code or other state energy codes. The HVI airflow data here is also, it's not as robust as it was before, but again, this is a very cost competitive option, would work well as a substitution for many ERVs that are kind of outside the passive house design criteria. 110 CFM, 0.4, 66 CFM at 1 inch, and then again, 76% SRE at 32 degrees, and then decent efficacy of 2.0 at CFM per watts. Somebody asked, do these need drains? No, these do not need drains. Everything that I've shown you so far is an ERV or an enthalpy recovery ventilator. So the only time you really would need a drain is if it's an HRV, which we don't typically like to sell in our market because it does get to be a high humidity area. And you end up with condensation that you do need to drain out. Now that it's not impossible. You can absolutely use an HRV. Just you'd have to know that you need to accommodate those drains. Good question. So as I talk about some of this stuff, just understand, HVI certified products are all available right here at hvi.org. Most of the screenshots I showed you were all straight from this directory. So if you ever want to check it out, all the manufacturers that are all HVI certified, all the ERVs are all right there. So just, That's where you go to HVI.org, click that button, and then go to section 3. So moving on from the in-unit ERVs, we're going to talk about central systems now. Now, this is an amazing unit. We're very lucky, very excited to have it. This SystemAir Geniox unit has a huge airflow range, up to actually 65,000 CFM, realistically closer to about 50,000 CFM if once you apply static pressure. But the passive house certified up to 10,000 CFM is including static pressure. That's a PHI certified unit. Truly a certified component, has that badge right there. So those are that's technically up to the housing size 27. So yeah, you can basically consider up to 10,000 CFM. We can deliver a truly passive house certified unit. That unit we can provide with up to 85% sensible and latent recovery efficiency. Somebody said, "Are you going to send this presentation?" This will be available on our website, just so you know. And the in-unit ERVs can be mounted in multiple orientations. Yes. Okay, so like I said, this unit can be up to 85% sensible and latent recovery efficiency. Now, that's understanding that the module, the wheel module actually can be oversized to the unit, to the housing itself. So the housing could still be a size 27 housing with an oversized wheel. Just the wheel module would actually kind of extend beyond the unit itself. Now, typically, a typical selection would be about 80%, a little bit higher than 80% sensible latent recovery. So like I said, it's a modular design. It's very easy to install. You can install these in the attics. Really pretty easy to install anywhere you need it. It's an indoor or outdoor unit where, and we can actually integrate this with any VRF manufacturer. So we'll talk a little bit about Fujitsu in a second. We could absolutely integrate Fujitsu with this unit, but know that we will not corner a contractor into buying our Fujitsu VRF with this unit. It's one of our go-to market strategies with this is that we will allow you to pair this with whatever VRF manufacturer you want. No problem. Those VRF coils are installed in the factory. The cooling options here would be chilled water, DX, or VRF. And then with heating, you can do hot water, electric, again, or VRF. What do you do for the frost control? Well, you could do preheat, you could do timed exhaust, you could do modulating wheel. We can handle frost control, no problem. So central system. So like I said, this is a very modular unit. I'm just kind of showing some other options here. It's a semi-custom AHU. There's a lot of different options available. One other thing that I wanted to point out is that we can do a heat recovery core, but know that that is a sensible recovery only. So you are dealing with just sensible recovery with that. And then again, know that VRF section would be provided by the factory, and then it would be adapted to the EEV kit in the field. And it can be used in any Geniox configuration. This is kind of like a sample of what the CAD or what the design CAD looks like. You can really get tons of different modular options available. And while this would be available to an engineer, just know that we would happily work through this with you as well. Yes, and Sean, good question. Yes, it does have hot gas reheat as an option. Just know that, I'm being forthcoming here. Our Fujitsu VRF currently does not have the option for hot gas reheat, but that's also why you could absolutely get a hot gas reheat coil from a different manufacturer. In fact, this is an actual Geniox example selection that I've used on one of my personal projects. I took this screenshot straight from one of my projects. Here we have a housing size Geniox 20, the airflow of 6,600 CFM at inch static pressure. The sensible efficiency, and note that this is not with an oversized wheel. The sensible efficiency from this wheel was 81.2%, and on enthalpic efficiency was 79.5. The VRF coil was mounted by the factory, and so was the hot gas reheat. So know that also we could do hot water reheat or electric reheat as well. And if I were to make that an oversized wheel, I would have added 4% without upsizing the actual unit. So you do pay for of course, the upsized wheel and wheel module itself, but that's, pales in comparison to the price of upsizing the whole unit, which you would not have to do. So here's some more stuff from SystemAir, kind of along these lines. These are indoor units only. These are the models FCU, FSU. Technically, they're the TR and FR. Sorry, I should have edited that. But it's an airflow range of 400 to 4,000 CFM. You can do counterflow or rotating wheel ERV options, and that's, again, with the counterflow, it'd be just heat recovery only, but with the wheel, you could get enthalpy recovery, and that's, again, around 80% enthalpy recovery. VRF integration with this is an option, but just know that it's not as simple as it was with the one that we just showed you with the Geniox. This is actually kind of external to the unit, and the controls, they don't talk to each other as well as the one that I just showed you. Let's put it that way. So moving on, we have another great central system DOAS that you would, I would really like you to consider for any of your projects, whether it's with a Group R building or beyond, any sort of commercial building. Up to 18,500 CFM. Greenheck makes it a really great air source heat pump unit that can pair with this. They also, of course, have gas, electric, hot water, or steam, or packaged DX, split DX, or chilled water. But know that air source heat pump does have a true 0-degree lockout. There's some logic baked into what it does between 0 and 10 degrees, but just understand that air source heat pump will not lock out above 0 degrees. Has, in most cases, you can get 70 to 80% enthalpy recovery ratio, which is, you need above 70% enthalpy recovery ratio for stretch code. That's from an enthalpy reel. And, you get really great construction from Greenheck, the 2-inch double wall cabinet with R13 foam. Always low sound condenser fans, and you can do side or bottom discharge. Any questions? Yeah, so it's funny. People keep asking me about a copy of the slides. Yeah, I will send you a copy of the slides if you need it. Just understand that this webinar would be available for you on your, on our website at buckleyonline.com. The training module will be there, and you can always share it with whoever else. Hey, Tom, you raised your hand. Do you want to speak? I'm sorry, I don't even know if that works. Okay. Tom, you might be active. I'm not sure. Okay, I'm gonna keep going. So we're kind of shifting gears a little bit, kind of along the lines. This unit right here wouldn't necessarily be compatible with a passive house design. It could be, depending on the enthalpy recovery ratio and sensible effectiveness you get. We can, in a lot of cases, we can get over 75% SRE. So don't rule it out, and let us know if you have that. We could absolutely find you a DOAS no matter what that would work with your system. Just keep that in mind. But along those lines, if you're working on a system that may not be passive house, consider this as an option. We have a vertical fan coil with ERV and heat pump integrated. This, like I said, this wouldn't necessarily be passive house compliant because your ERV module is actually integral to the to the vertical fan coil VFC. So, passive house wouldn't like that necessarily because it wouldn't be, it would be an integrated system. There wouldn't be separate ratings, but this has been a really great option for us. Oh, Tom, sorry, let me pause. Tom, yes, it uses this below 0 degrees. You'd go to backup heat. You could use electric heat or gas, of course. We can talk about that later, Tom. So with this unit, we've been involved in these types of units for a long time in this market. We've updated the core efficiencies to actually have pretty amazing core efficiencies. We integrate this with a Carrier MURA heat pump, and it has a high heat option, so it's cold climate with the COP minimums that are met. We've integrated an A coil in the heat pump and VRF format, so we can do heat pump or VRF. And this is a little bit wider than the one that we've typically had in the past. And we've always worked with DCNE to provide a Carrier heat pump or VRF system with this. But we can also always do a 2-pipe, 4-pipe DX or hot water. And that hot water can be NSF or central. So moving on, speaking of VRF, this is some big news. If you didn't catch, we'll be doing an actual VRF Fujitsu webinar coming up. So please sign up for that. We've got a lot of great information to share about this. So this will just be more of a teaser. But yes, we have signed an exclusive representation agreement for the plan and spec applied VRF side of Fujitsu. For a long time, I've heard from my clients, you guys got to get into VRF. And we never really felt like there was the right opportunity until now. I personally, and I know a lot of the Buckley team are very excited to get involved with VRF. Why? Because it's a premium Japanese product. Okay, so this is a well-established brand. We have tons of installations in the New England market already because they've been sold through distributor channels for years now. One sec. And just now they have been now looking to get involved in the plan and spec channel. So that's the perfect opportunity for Buckley to be involved because that's the type of work we do. We're not a typical distributor. We are now going to be going after the plan and spec market with VRF and mini split products. So why would we do that? Obviously, the electrification of the area, the energy code adoptions, making VRF technology a huge cost-effective design choice for these engineers. It's really something that we're looking to get into, not only just to be involved in VRF, but to also, complement our strong DOAS equipment that we just showed you. We truly believe that this is going to be a cost competitive option against the major competitors like Mitsubishi and Daikin. We stock it locally in New Jersey, but it's also available from Illinois, Texas, California, and we also have support personnel through the USA as well, including in New England. So not only will we be fully engaged in supporting this as a service and as engineering support, but we also will have the support throughout New England from Fujitsu as well. So it's a very high quality product, high quality service, and we're going to really engage the engineering team market as well. One of the ways we're doing that is we actually hired a product specialist. So we are fully invested. It actually even took us a little bit to announce this. And it's something that we're not taking lightly at all. We have a product specialist to really engage our team on all of the application selection, design assistance, submittal preparation, and approval. Make sure that we're coordinating all the equipment startup and commissioning, and handle all the pre-construction meetings. Sean is somebody that I've actually worked with personally for the last 6 years. He's a great guy. He's a great mechanical engineer. He actually was the department head for one of my clients in the South Shore. And he's somebody that's very familiar with VRF, and he's designed around VRF that I'm sure anybody that is familiar with VRF, you have designed around the same things that he's designed around. And it's something that he'll definitely bring some value to this team. So that's how we're handling the, Jason, I'm going to come to that question in a second. Sorry. That's something that we're really focusing on the engineering side, but understand that we're not just stopping there. Our service team, who I'm sure many of you know, are very familiar with Fujitsu now as well. That our service team goes out and fixes problems regarding GreenHack, Antec, price, and now they're going to know everything they need to know about Fujitsu. Those 8 field technicians that we have serving New England all report to Howard Bruckner, and we're going to be factory authorized for startup, troubleshooting, commissioning, installation supervision for all of Buckley's represented equipment, including Fujitsu. So, we're going to make sure that our contractors are also up to speed. Not only will the contractors have a requirement of just understanding what the equipment is, regardless if they've had training before or not, we'll make sure that they have a training. There's a mandatory training regardless, but there's also different levels of training that should be familiar. This is kind of a typical training format, I guess you could say. This is a pretty standard in the VRF industry, but yeah, we're going to offer different levels, and there's different incentives that come along with that. So Jason, to answer your question, yes, we are going to offer fully offer design support for our VRF systems. The system layout assistance that we're going to offer is going to include the system selection program. So this system selection program that we'll offer to you is the same one that Buckley uses, and it's the same one that Fujitsu uses. There's no there's no pricing involved. It's just rules baked into into the program to make sure that the system is going to work as designed. Okay, so on the right here, a little bit of a preview. We are also going to offer some mounting solutions as well, and it's going to involve that buck strut. I'll get to that in a second, but just to know that we're going full into this. We have a lot of different products that we'll be able to offer for the VRF market as a whole, including condenser support and platforms, line sets, filter boxes, and of course these pipe portals that we're talking about in a little bit. So regarding the supports, what does a typical IOM require? Well, you just need to make sure that's supported correctly, right? You have in the IOM, you have typical concrete support, H-beam supports kind of called out. But at the end of the day, it just needs to be fastened appropriately to a structure. And a lot of the times people end up using these quick slings, right? Quick slings are used all over for all different types, sizes, mini splits, even VRF systems. They're used all the time. There's all types of different platforms out there or homemade structures. But the point is, and also for the bigger stuff, there's the Bigfoots, and this is what we typically see. But our solution, I think, is a lot better. What we can offer is basically these 14 gauge buck strut mounting rails, which will absolutely support a condensing unit, but it's mounted to one of our, New England made roof curbs and equipment supports, and they can get some pitched options there as well. And one of the things that this offers that the quick slings or the Bigfoots don't offer is we can mechanically fasten these and flash these to the roof. So you're no longer going to have to, bind these up to other quick slings, right, in the field. This is something that mechanical contractors are already familiar with because this is something they use for, fans or whatever, any other equipment on the in the field. But it's something that we think is going to be absolutely worth specifying because not only is it better, it's less expensive than Buckley with the roof curb or condenser support. So pretty cool. I think this is definitely something worth specifying. And then when you compare this to a bigger quick sling or a bigger Bigfoot that again also needs to be assembled in the field, these would show up pre-assembled. We really can make these about a third or even a quarter of the cost. It's pretty impressive. So something worth considering. And how would you do that? We can actually send you these details. We have, it's something that you can carry on your drawing. I will be sending these details out. And I'm going to hopefully move through these slides pretty quick now that I think I have internet issues. It's a bummer. All right, so we're going to continue on. Filter boxes are something that Buckley's been involved in for a long time now. In fact, any VRF rep you can think of in the market has probably bought these filter boxes from us. Now we're just making it for ourselves. Just keep it in mind, this is something that we will now be pairing with our offering. Along those lines, we'll make sure that line sets are also accommodated. The line sets, there's been a lot of questions from some of my engineers making sure that they're code compliant. The code compliancy it really dictates your R value that you require. And then of course, when we don't offer a condensate pump in one of our indoor units, we'll make sure that it's included as part of our package. So moving on, the Buckley pipe portals. Hopefully you guys find this kind of interesting. This is something that we're excited about. A typical design detail would be look right there in the middle, and it typically would show up and get installed like right there on the right. But this is something that you can get all from us, and it can be completely custom sized, steel or aluminum construction with 1 inch thick 3-pound fiberglass insulation, removable hood, and custom knockouts available as well. So something to consider for your refrigerant piping. We're kind of going to be like a one-stop shop for all this stuff, and I think you're really going to like to do business with VRF rep that handles everything. So that's kind of what this is about. All right, switching gears a little bit. So this is something that it's kind of funny. So intake and exhaust. These are some intake and exhaust boxes. Very good construction, good quality. The louver face is very nice. It's a nice extruded vent. And typically the distance between those two is 10 feet. Now, something that happened recently is now that we're on 2021, All right, that's a bummer. So this is what we'd recommend. This is something that we can offer. Wall penetrations with dual intake and exhaust plates. Now this DVG model that you're looking at right here actually has a recirculation rate of 2%, air at 100%, 100 CFM. We have third-party testing to show that, and there's a lot of different configurations available: the DVS, DVV, and DV. But we could also offer a wall penetration detail to kind of go along with that. We're getting towards the end. Hopefully I don't cut out too much. Something else that you guys, I'm sure, are familiar with are the constant airflow regulators. This is from Aldi's. It's a really great way to kind of auto balance. You don't need to balance. All you need to do is make sure that you have the correct pressure in the ductwork. As long as that pressure is within the range listed, you'll get a constant airflow. So right here, you between 0.2 and 0.8 inches of water gauge, you get a 30 CFM. That's kind of what's shown right here. And then, of course, you can adjust that to whatever you need. So that car can be dropped into a register, a boot, or even a zoned register terminal. A zoned register terminal is a device where you flip a switch and a flap closes. You flip a switch down, flap closes onto that circle right there, where the constant airflow regulator is in the collar. Now, if it's a ZRT1, if it's a ZRT2, on that flap is another constant airflow regulator where when you close it, it goes to minimum flow. So you can go between minimum and maximum flow, or shut off to maximum flow. Now, note that this can also be a fire rated assembly. So it can be with or without fire rating, and it's a pretty good little device for some demand control ventilation. So along the lines of fire rated air distribution, this is our typical fire rated air distribution detail. It's a CRD boot with insulation, and on the face of it is a louver faced diffuser with an OBD on the back, and of course there's that CRD boot behind it. So this is a fully UL compliant CRD boot. Now, this includes the price LCMD, and a lot of the times contractors on these projects would like to substitute with maybe a less expensive model. And that's why I've come up with, or my team has come up with, a louver face design that's maybe going to save a few bucks. This is a Continental Industries AE, where that face, it looks a lot like the Price Industries option. And then if they want to save even more money, there's another option with the stamp grill, and that's the Continental Industries 2X. So it's got the multi-shutter damper on there, and all the other things to remain code compliant within that detail. So one more thing that's kind of related to Passive House. In Passive House design, you need to have a filter grill in the kitchen, and it's kind of tough to find a filter grill in the kitchen with constant airflow and within a CRD boot to keep it all UL compliant. But that's exactly what this does, and it does it at a pretty cost competitive way. It has the Continental Industries FG2 in the front, which FG2 refers to having that MERV3 filter that's required by Passive House. And yeah, this is just a good way to satisfy your code compliance in Passive House. So most multifamily construction will typically require or involve a garage ventilation. And I'm still surprised to this day to see how many engineers use duct systems throughout a garage, but that is by far the least effective way to do this, and it's not even a very cost competitive way to do it. These jet fans are by far the best way to eliminate dead zones in your garage, and they basically sit up in the garage. They're 6 inches deep. They'll suck in air and blow it across the garage. Across the garage from the intake to the exhaust. They entrain air throughout. They eliminate the dead zones, and they're all powered by CO detection. And one of the best things about this is that all you have to do to get a really good layout involving these jet fans is just send us an area or elevation view ideally, to us, and we'll get involved with SystemAir, and they'll send you a full layout like the one you see here. And if your owner or you are skeptical about the way it works, we can even provide a full CFD analysis. That's not what this is right here. I know it looks like some fun colors, but we'll provide you a real full CFD analysis that will justify the layout that we give you. Dry exhaust systems, we're getting towards the end, so come up with any questions you have here soon. But dry exhaust systems, we have a great partnership with LF Systems, and they do a really good job of providing a true dry exhaust system with a controller that can be both paired with a pressure, that can both operate off of pressure, but also a current sensor too. So yeah, and that can come with the inline link collector, and it's basically the full laundry exhaust system. So something we could do for smaller or really big systems. Anyways, that's it. Fortunately, we had a little bit of technical issues there. Sorry to say that, but yeah, I'd love to take any questions if you have them, and I'll get you on here if you want to. I think if you raise your hand, I can unmute you, but I'm not sure. Or just go ahead and ask questions. Okay, questions. Here we go. Those louvers you showed, they wouldn't work at the part 2 apartment, maybe 10 feet. Yeah. So Kelly, I also showed the I also showed the code section where, here, let me go back to it. So this code section, IMC 401.4, now that we're officially on 2021 IMC, we really can take advantage of this new rule where separation is not required between air openings. So the living space, exhaust air, and intake air can be now right next to each other. So you could use something like this if you wanted to. So something worth looking at if you're interested. All right, we got a lot of questions here. This is good. The details on the Buckley website. Not yet. We're working on that. How do the jet fans in garages accomplish exhaust? They don't. Okay, so the question is, how do the jet fans in garages accomplish exhaust requirements? Good question. They do not. They actually do not. They're not intended to accomplish your exhaust requirements. The whole purpose of this is to push air from the intake to the exhaust. Your code requirements for the intake and exhaust are still the exact same. What you'd be doing is just making sure that there's no dead zones by kind of pushing the air around. And there's still, still have CO detection, NO2 detection in the space. It's just, it's based on what you need. Good question. Yeah, I'll show the dryer vents again. Do you mean dryer vents? Yeah, so dryer exhaust, I mean, this is just like, we have, a lot of great options from smaller to really big systems. This is our typical laundry exhaust system. So, this would be really case by case basis, and we can even help you handle the makeup air side of it too if you need. All right. I think that might be it. We still have a lot of people on here. So if you have any questions, you know how to reach me, I think. There you go right there. All right. I appreciate everybody's time. Thanks again for joining. Please join the Fujitsu VRF presentation, heat pumps and VRF presentation we'll have later this month. That'll be a really good one. We'll actually have Fujitsu on the call to address a lot of questions you'll have. It'll be very informative. And yeah, thanks again for joining. Appreciate it.